episode of Tween programming. Today we are doing science. I am Kelly. This is Miss Mary Lou. We are coming to you live from the Scott County Public Library in Georgetown, Kentucky. You can probably tell something's a little different today. We are outside on the children's patio, which is technically closed, but we're doing science, and we didn't want to set off the fire alarm.
Yes, we're doing science today on chemical reactions, which means we're going to be burning some stuff. But last time when we did Tween Science, I hope you remember, we did physical changes. We looked at things that make things change okay, we talked about water. That was the simple one that we used, that when you either get it hot or you get it cold, the molecules in the water, they go faster when they're hot, they go slower when they're cold. When they get really cold, they compact together, they make ice. When they get really hot, they turn into steam, like a gas. But they always are the same structure of molecules. It's always H2O. Today we're going to talk about chemical changes where you do things to stuff that changes it and it doesn't go back to what it was like before. So we're going to look at chemical changes that are caused by a chemical reaction. And the way that you get chemical reactions is things can rust, like metals are exposed to elements, water, whatever, they begin to break down and turn into rust. You can burn stuff and it will change it, and it will never go back to what it was before. You can mix certain chemicals together and you get a reaction. That's how you get explosions. And we're going to do another whole thing on explosions later because that's just so much fun. Lots of chemical reactions that go on with cooking, just frying an egg. The chemical reaction there. When food goes into your body and your body breaks it down into nutrients by digesting it, that is a chemical reaction. And things that decompose, things that rot, the milk that goes sour in your refrigerator, the banana that rots in your fruit bowl, that is another chemical reaction. So these are just examples of chemical reactions, and we're going to do several demonstrations today of things that you can do at home to get a chemical reaction.
Yeah.
So
with proper supervision.
Yes, everything we're doing today needs adult help. So,
yeah.
Yes.
And we will be wearing our safety goggles. I have already fogged mine up. That's fun.
I'm not going to put mine on yet until we get to the more explosive stuff.
That's fine. This is very simple.
Yes, I was going to start off with when you put two substances together, you can get a chemical reaction. And a really fun thing to do is to make indicator juice, which is made out of purple cabbage. You just get some purple cabbage at the grocery store. You boil it for a while until you get a nice purple liquid.
And it's stanky.
It does smell bad, but that can become your indicator juice, and it tests the pH level. It tells you whether something is acidic or alkaline, and it's really fun because the color changes are really dramatic when you mix purple cabbage juice with stuff. But then I think we should just do a whole session on that too. So but that's something you can do. But what I did, I made another kind of indicator here, and this is something very easy to do at home. I took some Q-tips, and I took a spice called turmeric, which you can get at the grocery store. It's used a lot in like Indian cooking and other ethnic type cooking. I don't think we use it a whole lot in American cooking, but it's really good for you. So you can get turmeric at Kroger or Walmart and mix it with a little bit of rubbing alcohol, just a little bit, and then you can take Q-tips and dip them into the turmeric, and it turns them bright yellow. And in fact, I made these dipsticks today.
It's on your cheek.
It's on my cheek.
Yeah.
It's on my fingers. It's everywhere. It's lovely. But turmeric is another indicator, and it reacts to certain things to get a chemical reaction. And you're going to watch what I'm going to do here.
If you took part in our Harry Potter breakout room, you might have a good guess as to what's going to happen here.
Yes, we used this science in our Harry Potter breakout room. So
really fun.
This little dish right here contains vinegar, and I'm going to dip my dipstick into vinegar, and you can look and tell me, is there a chemical reaction? Has it changed color? No, it has not. I'm going to flip it to the other end, and this time I'm going to stick it in some rubbing alcohol. Okay, goes in the rubbing alcohol. Do you see a color change? No chemical reaction. why I brought paper towels.
They are here.
Thank you.
Yeah.
I am very yellow now. Another dipstick I'm going to take. Yeah, lots of wind out here today.
Yeah.
And I'm going to dip it into ammonia, which is sometimes used in household cleaning. And this is the part, you know, you would want to have an adult helping you with this, because ammonia is pretty nasty.
Yeah, don't breathe it in.
Yes. And don't mix it with anything else.
Yeah.
So, ammonia, dipstick into ammonia.
Yeah.
What happens?
It
Do
looks
you
like
see the chemical reaction? What
blood.
color is it? It's blood red. I thought you might really like this for Halloween. Yes, you can turn it blood red, but I think what's really cool, so this ammonia is very alkaline. So the turmeric is, this is what happens when it hits something alkaline. I'm going to put this back in the vinegar, which is very acid. And it doesn't completely go back, but it starts turning yellow again. But the molecule activity of ammonia is so great that you can even wave your stick over and it starts changing color just by being in the vicinity of the air. But you stick it in and it looks just like blood. Yes. All right. There's that little demonstration right there.
blood.
Yes. Another chemical reaction, I'm going to kind of do the first part, and then Kelly gets to do the really cool stuff.
Okay. Well, we'll do it together.
Is burning stuff. And
Yeah.
what I am going to burn here, this is steel wool that you can get at, I think I might have gotten this at Lowe's. I can't remember.
You get it pretty much anywhere.
You want to get, well, it's actually, no, you can't.
Really?
Yeah, I had a hard time finding it.
Oh.
But I'm pretty sure I got it at
Never
Lowe's.
mind.
And you want to get a very fine grade of steel wool. You don't want the kind that you would get at like Walmart that has soap in it.
The
No
Brillo
soap.
pads?
Yeah, no Brillo pads. You just want really plain, fine grade steel wool to do this activity. And this is one, I am going to put my goggles on it because I'm going to burn something. I have taken, oh boy, I'm sure this is really attractive too. I am going to take this steel wool and I really fluff it. I fluff it a lot, and it's almost like kind of really kind of coarse hair, you know, something like that. And Kelly, you want to light this bad boy?
Sure do.
This is the part where you need adult help. We're going to set this sucker on fire.
Get it from the front.
And it's just really pretty how it burns. Oh, it's so pretty. Yeah, and burning always gives a chemical reaction. Ta-da.
It's like sparkling.
It's just so pretty. Yeah, yeah. And if you're into electricity, like if you're learning about electricity, you could even rub a fresh, we tried it, our batteries we found out were dead.
Yeah.
A fresh 9-volt battery, you can just rub the terminals over this and it will start, it completes an electrical circuit and starts the so there is our steel wool that is burned. And I'm not going to touch it now because it's still pretty hot.
Yeah.
But it crumbles now. It's not the same, you know, steel wool is a very strong fiber. Well, now we have completely broken down the fiber. It's very powdery, it's much lighter, and it's darker in color. So, and there is just still kind of a lingering burn there. It's real pretty.
It's like twinkling Christmas lights.
Yes, yes. All right. That was activity number 2. What else have we got, Kelly?
All right. So, I'm going to take those off because I am fogging up like,
Yes,
whoa.
Me too.
All right. Let's do some snaky bits.
Yeah, let's burn some more stuff.
Let's burn some more stuff.
And again, if you came to our Harry Potter breakout room, this was another piece of science that we used in that event.
Yes.
This is how we created our basilisk.
Yes.
Yes.
You had to escape from the Chamber of Secrets.
Yes.
All right. So, step 1, you want a little tin. We're using these disposable, although we reuse them, tins.
But something fireproof, absolutely fireproof.
Yes.
It could be even a baking dish if your mom or caregiver's okay with that.
Yeah, although you're going to be putting lighter fluid in it, so keep that in mind.
Yes.
And we have craft sand. If you've got sand from a sandbox, you can use that too. This is just going to create like a base So I'm just gonna pour a ton of it in here.
But whatever sand you use, you cannot reuse it again.
Yeah,
so
no.
just be sure that it's okay to.
I learned that when I was a kid, when I poured lighter fluid in my sandbox, and my parents were like, "Kelly, what's wrong with you? Now you've ruined it." True story.
He's making a little crater with it there.
All right, and I am going to see if I can get it open. Oh, haha! I had trouble earlier. I'm gonna just douse this entire thing in lighter fluid. Whee.
This is gonna be another good Halloween activity.
Douse it.
Yeah, you want that sand really soaked.
Yeah. All right. Pop that back. All right. So the two things that we are going to be mixing are baking soda and powdered sugar. Well, let's get that and get my little baby bowl. That's what the empty bowl's for. I knew I had a purpose. All right.
It was flying across the.
Okay. All right. So we're going to take 1 teaspoon of the baking soda and 4 teaspoons of powdered sugar, icing sugar.
There goes my cake for this weekend.
1, 2. Whoop! I got hit with a pine needle. 3 and 4. Do you want to double it? Make it extra fun?
Oh,
That's a yes.
go for it, Kelly.
That face is a yes. So here's 1. 2, 3, 4.
Do you need another teaspoon
And we
of
need
baking
another
soda?
teaspoon of baking soda.
I'm just using my fingers to mix this up because there's nothing toxic here.
Yeah. Baking soda and sugar. We good. All right. 1 more.
Great. And do I just pour it in the middle, Kelly?
And just, mix it all together and pour it in the center there where we kind of made a little divot.
Okay, so did you get those measurements? What was it again?
It is 1 teaspoon of baking soda to 4 teaspoons of powdered sugar. We did double it, so we've got 2 teaspoons of baking soda and 8 teaspoons of powdered sugar.
Yeah.
I shall hand this one to you as well.
Thank you.
All right. I'm going to goggle up now.
Oh, goggles, yeah.
Yeah, goggle up.
Stuff is gonna burn.
Safety first. All right. So I'm going to set this sand on fire. And then let's see what happens here. Come on, later. I know it's windy and you're angry.
It smells like a cookout.
It smells like marshmallows.
Yeah, I was gonna say, let's get the marshmallows out.
Because of all that sugar.
That's right, that's right.
And watch, it's starting to bubble and mix and burn, and it's shooting up approximately snake-like. The test we did earlier,
Yeah, it worked really well.
It kind of looked like a chameleon at one point. It was really fun.
This has got lots of little snakes. Lots of
Yeah.
snakes. Look at those guys coming out of there. And this is the chemical reaction that happens when sugar burns. Just like if you're like me, I like my marshmallows really black.
Toasty.
Yeah, I set mine on fire. I love them like that. And there's your chemical change as it turns, the carbons come out. Yep. Is that not cool?
Ooh, yeah.
When we did the Harry Potter breakout room, you know, each team got to do this, and some of them were kind of very small. There was one boy's, his was a huge snake, and it just kept coming and coming and coming. It was just,
It's
it just
crazy.
went on for the longest time. It was so cool. Well, should we set up the last one while this
Well, this is
continuing?
This
Because this could go on
lots
for
of.
a
It
while.
could go for a while because
Yes.
there's some lighter fluid. Woo!
I'm just gonna try to get it.
To the edge of the table. Oh, oh!
Don't
oh.
do this
Don't
at
do
home.
this.
There we go. All right.
All right. All right. I think yes. I've done with the lighter.
Got it.
Okay. So last one.
This is a famous activity.
Yes. called Elephant Toothpaste. Oh! My goggles are so foggy. Alright. And some water.
How can I help?
I don't know.
Okay.
I think I need that one, I need the big one.
Do you need a funnel to get the peroxide in?
Probably.
Okay, should I go get a funnel?
I guess so. Do we have a funnel? I hope we have a funnel.
We have a funnel.
Okay, well then, yeah. While Miss Mary Lou is going to get a funnel, I am going to start this up. So, we are going to start with an empty bottle. I'm going to put it in the middle of a pan. This is just because this experiment can get messy. Now, we're hoping this one works. We didn't test it this morning because we only had so much yeast and peroxide, so we didn't think we had enough to do it twice. And we didn't want to just do it and not show you all. That's no fun. So, we are going to start with our bottle. Never tried it this close to fire before. This will be interesting. And we are going to mix 2 tablespoons of warm water. I have got this here. It was from the tap. It's even more warm since it's been sitting outside here. Let me find. Nope, that's a teaspoon. But I'm pretty sure it's 3 teaspoons to 1 tablespoon. So let's clear that of any baking soda because I don't want to mess it up. Alright, we want 2 tablespoons of water. So we're gonna do 6 tablespoons, or no, 6 teaspoons. I know measurements. 6 teaspoons. 1, 2, 3, 4, 5, 6. Alright.
Kelly, I could not find the funnel, but I found this measuring cup with a spout.
Perfect. It is 3 teaspoons to a tablespoon, correct?
Sounds good to me.
Okay.
It's pretty close.
And 2 teaspoons of yeast. Theoretically, a lot of you maybe went through a bread making phase here at the beginning of Corona, so you probably have some yeast on hand. I stole this from my mother. She doesn't know that yet.
Probably just the whole packet, right? That's about a tablespoon. Usually a packet of yeast is a tablespoon.
Quarter ounce. I don't know what that means.
It's a tablespoon.
Okay. Is that? It says 2 teaspoons, so not quite. Let's see what it does for us.
Okay.
1. Yeah, close enough.
Your water's not warm anymore.
Really? It felt pretty warm to me.
Okay.
All right. Thank you. Let's see. We're gonna swirl
Oh,
that.
they got water, warm water there. Never mind.
What? Okay.
This is not scripted, guys.
Nope. If anybody was under that impression, they shouldn't be. Do you want
Let me
to?
get on this side so I can hold this. for you.
Yeah, and we need to mix our peroxide.
Alrighty, you need half a cup.
Yep.
Alright. Now, if you want to do this at home, it's really important you get the right kind of peroxide because it will only work with this. And you have to go to a hair salon place to get it. So there's a hair salon place over kind of in front of Lowe's. I think it's Sally Hansen's is the name of it. And you need to get the 20 volume peroxide to do this. It will not work with the grocery store version of peroxide. Kelly, how much do you need? Is that half a cup?
Half a cup.
4 ounces. I think this is what people use to bleach their hair.
Yes. That's clear developer.
Now what do I do? Do I
All
put it in
right.
the bottle?
We need couple couple droplets of food coloring and some dish soap in there.
In the peroxide.
So says the instruction sheet.
We got it. We did not test this beforehand,
Yes.
although we have done it before here. It's just been a while. There's that. Food color. We're gonna make
It
green.
just says a squirt of dish soap.
And a squirt of dish
A
soap.
squirt.
There we go.
All right.
It's very pretty.
It is very pretty. So that goes in our water bottle.
Okay, here we go, guys.
I'm gonna move this back. Apologies for that terrible noise.
That sugar smells so good.
Also, secondary chemical reaction, it has changed the color of the sand.
Yes, it has. It's made the sand brown.
Okay, well, let's see if... I don't know if this yeast is gonna work. Let's find out.
I'm standing back.
Okay, I'm gonna pour it into this... Oh, no I'm not. No I'm not.
So if this doesn't work,
Because the water wasn't warm enough, the yeast didn't activate.
we'll see.
Yeah.
But you can do it at home. Whoa, whoa, there it goes, Whoa, there
Woo!
it is. Beautiful.
And of course it's squished out the other side
There we
where
go,
you
there we go.
can't see it.
Oh my gosh, and it's hot. If you could feel the bottle is actually hot.
Ooh, it doesn't smell good.
Woo! Kelly, feel the bottle. I mean, it's not like burn hot, but it's
Oh, but it's warm.
very warm.
It's warm.
Yeah. And that is elephant toothpaste.
Yeah. All right. So, that is what we have got for you today on Tween Science. We will see you back here next... Oh, we're getting rained on by pine needles.
Yes, that's
Woo!
so you've seen all kinds of varieties of chemical reactions. We hope this helps you with your science learning. I don't know what we're going to do next time. I don't think we have a plan.
For science, no. But next week, we're doing book bites.
Book bites.
Halloween stories.
Yes, scary stories.
Woo!
Yes.
Yeah. So we will see you then. And until then, stay well, guys. Bye.
Bye.